Hi, welcome to this STAIR Tailored. I'm Sarah Powell from the University of Texas at Austin, and right now we're going to focus on mathematical language. Now, math language is really tricky, and I'm going to talk about 11 areas where math language can be tricky for students, and these all come from a really nice article by Rubenstein and Thompson from 2002. But math vocabulary can be tricky because there are some math terms that can also be used in general English. So for example, a degree might mean your high school degree. It could also mean the degrees of an angle. Math vocabulary can be tricky because there are math terms that have a similar meaning in general English, but the math term is more specific. So you might be talking about the difference between like two people's outfits, or are you talking about the difference between two numbers? That's much more precise of a question. There are some math terms that students haven't heard before because they're only used in math. Have they heard the words parallelogram or trapezoid or numerator? So we have to explicitly teach those. Math vocabulary can be tricky because there are some math terms that have more than one meaning in mathematics. So for example, base could be the base of a three-dimensional figure. It could also be the base with an exponent. Math vocabulary can be tricky because there are some terms that students may have heard in another content area. So perhaps you're talking about an algebraic variable, and in science they've been talking about things that are variably cloudy when they're talking about weather. Math vocabulary can be tricky because there are some terms that are homographs. So for example, if you hear a teacher just saying sum, does that mean the sum when numbers are added together? Or I just want you to grab some of the blocks? Another reason that math vocabulary can be tricky is because there's a lot of terms that might have similar meanings and students may confuse them. And we'll talk about this in just a few slides. But what is the difference between hundreds and hundredths? Those are hard for me to say. And what's the difference between numerator and denominator? Math vocabulary can be tricky for some students who are English learners because there might be terms in their native language that then they may confuse with some of the math terms that we use in the English language. Math vocabulary can be tricky because there might be different ways to spell things that are pretty similar. So for example here, what is the difference between F-O-U-R and F-O-R-T-Y? There are some math concepts that we might talk about in different ways. So for example, one teacher may ask you to do some skip counting. Other teacher may ask you to work with multiples. Those are the same thing, but we're using different language to explain these different concepts. And math vocabulary can also be tricky because many times we use informal terms for what we mean for meaning formal things in math. And I'm going to talk about that on the next few slides. So first, we have two recommendations when we're thinking about formal math language, or thinking about the language of math. First recommendation is to use formal math language. And now here are a few examples from middle school that might be important to think about. And these top few examples, here might be something that we say currently, and here might be a better way to say that. So instead of saying the numbers that you add, we should be calling those add-ins. Instead of saying the numbers that you multiply, those are factors. And instead of asking for just figuring out the answer, be specific. Are you asking the students to figure out the sum, the difference, the product, or the quotient? When we're thinking about comparison numbers, instead of saying bigger or larger or smaller, those really refer to size. Think about the numbers that refer to quantity, and that would be greater or more or less or fewer. Here are a few other examples. We really hope that you're not saying top number and bottom number because a fraction is one number. So instead of saying top number and bottom number, we should ask about the numerator and denominator. Instead of asking students to reduce fractions, we should say simplify or find an equivalent fraction. With decimals, we should really talk about the decimal point as being the kind of the connector between whole numbers and rational numbers. So we don't want to say point, but we should say and. So it's 1 and 29 hundredths. It's not 1.29. And here are some suggestions when we get to thinking about algebraic concepts and integers. Instead of thinking of it just write the opposite sign, that's actually talking about absolute value. And remember that the minus sign and the negative symbol, those are actually different. So if it's minus, say minus, and if it's a negative symbol, say negative. Now there's also a few considerations when it comes to geometry. This is not the corner, that is an angle. this is not a square. I hope you don't say that, but that is a rectangle. And remember that all squares are rectangles, but not all rectangles are necessarily squares. With these three-dimensional figures, we might use informal language. So instead of saying box, we should say cube or rectangular prism. And instead of saying ball, we should call those spheres. And then here are some suggestions for how to use, take our informal language and make it more formal when we're thinking about the measurement of different objects. Here are a few other suggestions too, with things related to parallel lines or perpendicular lines and parallel lines. And then some different things related to, is this the center? No, it's actually the apothem. Is that the center? No, it's the origin. Is this the top? No, it's the apex. So remember, instead of always using the formal language of math, we need to help students understand that, instead of using the informal language of math, we need to make sure that students understand the formal language of math. So the first recommendation related to using strong mathematical language is to use the formal language of mathematics. Our second recommendation is to provide specificity to different terms. And let me show you a few examples of what I mean. So here are some examples of terms that students often use interchangeably because the terms have similar meanings and the students may confuse them. So a big one is factor and multiple. Those are different terms that had different meanings, but a lot of students will use those interchangeably. It's the same thing up here with some of our things related to algebra. What is the coefficient? What is the constant? What is a term? What is a variable? You need to make sure that you're defining and using these terms with specificity so that students do that too. Here are some examples with how we talk about numbers. Here are some examples with how we talk about fractions. And here are some other algebraic examples, making sure you're talking about the difference between an equation, an expression, a formula, a function, and an inequality. We also have lots of examples from geometry. This is an area that's pretty ripe with a lot of confusion for students because so many of these terms students use in an overlapping manner when they should use them and define them separately. So here are some examples with quadrilaterals and with angles and with triangles. Here are some more angle examples. Are you talking about complementary angles and supplementary angles in the correct way and providing specificity with those terms? A lot of students will just use the word same for congruent figures and similar figures when they actually are congruent figures and similar figures. There is a difference between the line of reflection and lines of symmetry, in the same way that there's differences in how we talk about transformations, how we talk about things related to the coordinate plane, how we talk about things on the two-dimensional figures and three-dimensional figures, and then the specific terms for lots of different three-dimensional figures. So remember, you need to provide specificity with the terms that you are using so that students don't confuse these different terms. So some of our suggestions for instruction include the following. Have students make their own math journals where they can make glossaries of specific terms. You might have them make Freyer models to help understand terms that can be easily confused. So what is the difference between a reflection, a translation, and a rotation? You might create some word walls. You can buy teacher-created word walls, but student-created word walls are even better. Do make sure that you don't put these word walls and defined by operation because there are no specific terms that mean a specific operation. So for example, share doesn't always mean you're going to divide, and we talk about that in the STAIR Tailored on problem solving. Other suggestions, students can be playing games. There's crossword puzzles and all kinds of technology games out there. There's also things that you can do related to explicit instruction. So here's an example from an intervention that we ran with students, and we were focused on teaching these three terms, add, plus sign, and equal sign, and we used explicit instruction. So we used the modeling and practice opportunities to help students actually understand what these words mean. Finally, you just have to think about how students are going to access math language. So students are listening to your math language all the time, but are you giving them opportunities to speak the language of math? Are students given opportunities to read within the language of math? And are you giving students opportunities to write within the language of math? Students need to practice their math language in all these different ways, and you need to provide those opportunities for students to do so. So thank you so much for tuning into this STAIR Tailored on mathematical language. Remember that you need to use use the formal language of math and provide specificity to the terms that you're using.